Okay. Hello everyone, good morning. My name is Uddesh Soman, and today we are going we are going to look at some basic text processing techniques. So whenever we have text-based data, like for example, here we have some text tweets. So we need, in order to put it into our any deep learning model or any text processing natural language processing model, we need to actually first process the text or simplify it. Otherwise, we might encounter some error, and hence text processing is needed. So, couple of steps in text processing, why they are needed, and how do we do that? I'll explain as we go. So, first of all, let me give you an
So,
introduction to.
Udesh, actually, if we can give the agenda from the top. So, this
Yeah.
is basically a session of text pre-processing. So, we are, as explained by Udesh, we are cleaning the text before putting it into our vectorizer, and after that, we'll put it into machine learning model. So, before vectorizing the text, we need to do a lot of cleaning for the text because emojis will be there, the exclamation marks will be there, some other punctuations will be there. So many other mix of upper and lower case will be there. So many such things like some stemming limitization is needed because run may be used in run, runs, running, those kind of things. So we have to convert it into base form. So we have learnt about stemming limitization. So those things should be done. And if it is a tweet and all, so we have a lot of emojis. So if you remove the emojis, you are losing very valuable information. So in text pre-processing, we have options of converting those emojis into text. Emojis can be converted into text. So that once you convert it into text, means you can process it very easily. So in the next few steps, I think in front of you are there are a lot of pre-processing steps like lower casing, removal of punctuation, removal of stop words. So stop words we have already discussed where stop words are very commonly used words and use of very frequently used words. Some words are very rare, used are only once or twice in your corpus, text corpus. So there we do that we don't want. Stemming lemmatization means different forms of verb like run, running, runs. You have to convert it into base form run. Then emojis, either you choose to remove emojis, but if you remove emojis, you lose a lot of information. So something that is called emoticons. So some emojis is a separate category, emoticon is a separate category. So you need to remove emoticon actually if there are any present in your tweets or that kind of data. Then if you don't want to remove emoticons or emojis, better to convert them into words so that you don't lose information content there. If there is a smiley emoji means tweet is positive. If there is a reverse emoji means the tweet is negative. So you cannot afford to just delete the emojis. So you have to process them. Then your data may contain a lot of URLs. So that URL should be removed. HTML, if data is scrapped from HTML website or you are reading a HTML website, those HTML tag should be removed. Then chart words like there are a small form used for like buy for now. So people use BFN. So those things should be converted into proper words. And after that in the last, you have to correct the spellings in the text, like whatever wrong spelling is done. People do a lot of misspelling while typing on mobiles and even on laptops. So after that, you need to apply a lot of spelling correction. So these are some of the basic text pre-processing steps that we'll be discussing today. How to do that in the code. Okay, all yours, Soman.
So, thanks for the nice introduction, sir. Now, let me move to our data set. So, here simple data set we have. It is some data set from Twitter, author ID inbound or created at. What we'll be interested in is this text column because we'll be processing the text, and so we just take this text column out of our data set. That's all we need for text processing. So simple thing first we check is text dot lower. we can convert whole the text into lowercase. Why do we need to do that? Because sometimes we use capital words, sometimes we use uh, whole in uppercase, whole word in uppercase. So what happens is, because computer or processors run on ASCII code, they treat them as two separate words instead of single word. Like this private here would mean different, and private here would mean different for a computer. So in order to prevent that, we convert the whole thing into lowercase. As simple as that. We just need to call str, string class, and lower method. We just have to call these two on our data set or a particular column, if you so. And thus, that's all. We get it in lowercase. Next up is removal of punctuation. Punctuations actually don't hold much of meaning and actually end up as gibberish in our processing. That's why we need to remove the punctuations. In order to remove punctuations, we need all the punctuation as list. So first of all, in string, the string class, we have punctuations available. So we just call string dot punctuation, and all the punctuations that are available are now transferred into this list. Next up, we create a customized function to remove punctuations. So here we have the translate method. What this translate method does is actually takes a function and translates accordingly, whatever the translation function we define. So instead of defining our own function, we are going with make trans, that is already available in string class. So what make trans does, if the first two arguments are actually target and replacement. So if you have a particular target, then you can add replacement here, because we do not have a particular target but multiple punctuation marks. So we are leaving this one blank, replacement blank, because we need to remove them. We are not replacing them with anything. We are totally removing them from our data set. Hence, we are replacing it with blank or null, anything like that. And another is punctuation. To third argument is actually list of targets. So in case instead of a single target, you have multiple targets. Here we have multiple punctuation marks as our target. So we pass them as list. So for the sake of this particular function or this particular case, we only need these two arguments. The second one, that is replacement, and the list of targets. And what we do is return our text translated by this function. So what it will do is, actually whenever it encounters a punctuation mark in our string, it will replace it with blank. So we'll get rid of the punctuation mark. That's all. To apply it on data frame, we have to call lambda so that it applies it on each and every row. So lambda text means any variable that you declare, any variable. And what to do on that variable is, we call this function, remove punctuation. So each and every sentence of our set will go through this function, remove punctuation, punctuations removed, applied back to our data frame. And we create a new column for that, text without punctuation. So here, if you see, we got rid of the @ sign, the full stop in this column. We do not have all these signs. So that's how you remove punctuations. Removal of stop words. So as we have seen in previous classes, there are a couple of stop words in English language. Like there are some common words which do not add much to the sense of sentence, or any uh, any target, and do not serve anything with the target. So we call that. They are available in NLTK library. So first of all, you'll have to download the stop words package. It does not by default with the NLTK library. You have to download it separately. So just call the NLTK download stop words. You'll After these are downloaded, we can just import it from NLTK corpus, import stop words, and we just In order to see them, we are just creating a single string out of them. So uh, separated by comma, join stop words. So here are the available stop words that we have in English language. Now, in order to get rid of any duplicate words, we just call the set. So any duplicate words will be removed, and we'll just have all the unique entries of stop words. Again, the function is quite similar. We take a for loop. So if the word is not in stop words, for each word in text dot split. So first of all, it will split our string. Whatever string we pass, it will be splitted into each and every word. Like 115712 will become a separate string. I will become a separate string. Understand will become a separate string, and all that. So here we'll have a list of separate strings, means each and every word of the sentence. If it is not in stop words, if that particular word is not in stop words, it will be added to the word. It will be added to this final list, this external list, this one. So whatever the result will be, it will be our whole sentence in the form of a list, without the stop words. When stop words removed from our sentence, and then we call the join and join with space. So all the entries of list, every word that is available in list will be again joined into a single string separated by space. So the final output we'll get is this string. So if you see here, let's take some example here. This print care, and how do you propose we do that? So here, and how you we do that. These were the stop words that were available in this set, and we have removed them from a sentence. That's how we remove stop words. The similar thing we can do to remove frequent words as well. So first of all, we will need to get the most frequent words, because the most frequent words actually do not make much sense, since they are very high in number, and don't add too much to the specific sense of the sentence. So in order to do that, we will need to remove the most frequent words. So we just call the counter. We make a counter object here, and we import values. So for word in text dot split, count is equals to word plus one. So for each sentence in our data set, which means for each entry, it will break it into words again, like it did earlier with split method, and then it will increase the count of that word. It will be in the form of a dictionary. So here we'll get in this form words and count. So first of all, we need the set of most frequent words. So here word, this is actually list concatenation in Python. So word for word in word count. This is the tuple. So if you see here, we have in the form of tuple. We have word and word count. So count dot most common, we call that. So here we are calling 10 most common words. 10 most common words. And of that, we are only going to take the word. The return is word and word count, but we are only going to take the word. That, and we convert it into set, just to move if there are any multiple words. Next up, we make this function in the similar manner like earlier. Word for word in string text dot split our text. We split it. If the word is not in frequent words, we join it as a string. And again, we call this function using lambda, apply lambda, and we get this. So without stop frequency, if you see here we have I understand, I would like to assist. So I is not in this sentence. Two is not in this sentence because those were in the top 10 most common words. So they are removed. Similarly, we can do it for rare words because extremely rare words again do not make much to the sense of sentence. So in order to do that, we again call the same method. We need n rare words. So from uh, from our most common words, we actually take only n minus. We only take last 10 entries. So how do we take the last 10 entries? Python, we can just give the index all to n rare words and in the step of -1. So actually it will do in reverse order. From the end of list, it starts in reverse manner. So what's important here is this -1 step. Once we are done with that, we have a set of rare words, the words that are least common in our data set. We join them. Sorry. We call the text.split. If it is not in rare words, we consider that word. We convert it back into the string, and we apply this function on our data set. So here we have, I don't think it will, in the first column, it is going to appear. But yeah, the way frequent words are removed, the rare words are also removed. Again, just see this comment, we can combine these three lists. We had stop words, we have frequent words, we had rare words. We can combine them in a single set or a single list, and then we can remove them altogether instead of doing three separate steps like we have done. We can just make a single list out of these rare words, frequent words, and stop words. And by the same function, we can remove them. Now we come to stemming.
Yeah, we
Stemming,
can we make
yeah.
we can yeah.
Okay, so now we come to stemming. Stemming is actually, we have seen earlier that stemming basically removes the suffixes and makes them into the simple words. So for here we have here for stemming we have porter stammer. So first of all, we do not need these columns. We import the porter stammer from an analytical library.stem, and we create an instance of porter stammer. Next up, we just split our text again because we need to do it for each and every word. So we split our text, and for each word, we pass it through the stemmer in stem method. What it will do, it will take each and every word, it will crop it, means it will remove the suffix and then return the word. So that will end up as in the form of a list, and calling the join function, we'll convert it back into a single string. We again call the lambda to apply it on, and let me see an example. Yeah, here we have the word please send us a private message. And the stemmer had actually converted in thought e as a suffix, so it removed e, and we have pleas, please private. It removed e from private as well as message. Here in several, it removed al. So that's what Porter Stammer does to give simple words. But again, you can see since most of the words have lost their meaning because they are converted into incorrect spellings. Since it just removed the suffix instead of giving us the root word. So let us see what we can do if we need, because the Porter Stammer is actually available only for English language. If you want to check for another other languages as well, there is Snowball Stammer. So these are all the languages available in Snowball Stammer. If you need any other language, you might as just check on the internet which of the stammer object is available for other languages. Next is Limitization. Lemitization we have seen, instead of just removing the suffix, lemitization converts the word into its base word. Now the base word actually could be noun or verb and all that. So we are going to see that. So first of all, we need to download the WordNet. WordNet is actually WordNet actually contains all those words. So we download WordNet from, then we import WordNet Limitizer, and we create an instance. And this process, rest of the process is same. We just limitize the word from by using text.split. We limitize each and every word. We get the list. We join them into a single string, and this function we apply using the limiter, and hence we get the limitized text. I think here should be one of the example. Okay, it hasn't done anything here because most of the words are, you know, base words themselves. Uh, but
Just you
okay,
can just a second, someone. You can see here. Just see on the second entry in the text, and you see text is stemmed. So text stemmed word is purpose in the second column. Purpose. So PO, then stemmer has done is PROPOS, and the stemmer has given the proper word. So stemmer will always give you the proper root word, and sorry, the lemmatization will always give you the proper root word, and stemmer just removes the suffix. So suffix, the stemmer is a quick and dirty verb. Lemmatization is a proper verb, but more computing is required. So that's the difference. Depends on you how you want to take it, your analysis.
okay. Now, uh, just to give the example of lematizer, here we have lematizer. We lematize, and we lematize the word running. But you can see here it again is running, because running is a valid word, right? So instead of just giving simply the word, we can provide part of speech. If you provide part of speech, then it will go into the base word based on the part of speech. Like here we have running. So we running is actually becomes a noun. So instead we add the POS tag. So here we are adding POS tag V for verb. So we get the verb form of the word. For running, if we call lematize with the verb tag, we get run. So hence POS tagging is actually needed to get the
So much just
that
as an experiment, in
uh,
the create one cell and try running as noun. Well, let us see what comes. Your,
yeah,
here only, down only you create a.
sir, I'll have to import them again. Na?
Okay, so then you take, then you don't do all that. Let us see. Go ahead and we can see it later.
There is an example ahead. Na?
Yeah, another example. You need to zoom it a bit. Yeah. Okay.
So
So go ahead. Go ahead.
here we have the word stripes. Okay. Now first we pass it through the noun tag. Pass it separately through verb tag and noun tag. So if we see the lemma or the base word for in word, a verb, then it is strip. Strip is the verb lemma of stripes. And if we see the noun word, then it is stripe. So that's how we can pass different POS tags, and we'll get different results or different lemmas based on our POS tag. Okay. So in order to do lemmatization in that manner, we'll need to download average per second tagger. After downloading, we import the corpus wordnet and stem wordnet lematizer. From this, we can get all these words. Like first of all, we need to create a map for that. For each and every word, we need to create a map. So N stands for wordnet.noun. Any word, any noun word is is denoted by N. If it's a verb, then V. J for adjective, and R for adverb. So we lematize the word. First of all, we take whatever the text is, we split it with POS tag. We are not we are not just simply splitting the text, but we are also adding the POS tag. So this POS tag will be NLTK POS tag. Like earlier, we have seen this V and verb and noun, all that. So we take this POS tag. Now we here this one is bit complicated this making. So for word and part of speech in POS tag text. So we take word that we lematize the word. And how do we lematize it? We need to determine whether to lematize it for noun verb. So how do we determine it? So wordnet map dot get. So whatever be the POS tag of it. So POS tag I think appears in the form of list, or if a word belongs to multiple POS categories, that's why. So we just take the first category that we get. So from this dictionary, we call the get function. Our key is POS tag 0. So whatever be the first POS tag of the word, whatever word comes through here, we POS tag of that word. So in case a noun word comes here, so get N. And for that POS tag, we'll look up in this dictionary and we'll lematize according to that POS tag. So if we get noun, then it will the return of this dictionary would be wordnet.noun, and the word will be lemmatized according to noun. In case it is a verb, then it will happen for the verb POS tag. Again, in case POS tag is not available or POS is conflicting in nature, then by default we instead of making it a blank or raising an error, we just go for wordnet.noun. In case no POS tag is available or there is some conflict between POS tags, we go for wordnet.noun. So whatever be the POS tag and the word select, we lematize that word, and this particular process happens for each and every word. And after the result is we get a list of POS tag words, POS tag lemmatized words, and all those lemmatized words are converted back to this string. So we apply again the lemmatized words using lambda on our data set, and our uh, we get this kind of output. So in case anyone has problem with this or any confusion with what happened here, I can explain it again, please. Or any confusion in any part, because bunch of functions are nested within each other. That's why. If anyone has any doubt, please ask or I'll continue. Hello? Hello, am I audible?
Yeah, you are audible.
Okay. Okay, fine. Then I'll continue. So here's an example in the third row. Send. I have said this. I have sent. This is converted into send using POS tag lemmatization. The- Because most of the words here are actually the lemma itself. So here I don't see much change, but there are changes in our full data set. One of the examples is this sent was converted to send. So next up we have removal emojis, because in this removal, as sir explained earlier, emojis actually add up to the significant information in our data set, because emojis, there are expressional emojis, there are other emojis that signify something in a sentence. People use emojis as a shortcut for text. So the thing is, by default we shouldn't be removing emojis, but in case we do not want emojis for a particular application, not going to detail, but for a particular application, if we do not want emojis, then we need to remove emojis. How do we do that? Emojis cannot be removed this simply. We need regular expression. So for regular expression, there is library RE in Python.
Just a
From
second, just a second. See, so friends here, regular expressions you need not worry because I will take a separate class on regular expressions. So right now you can take it for granted, and when we cover it in the class, regular class, it will be more clear to you.
yeah, so we just get our emojis pattern. So emojis are actually, you see, these are images. Technically, these are images. So how do we classify each emoji? So for each emoji, we have a hexadecimal code. This hexadecimal code actually represents an emoji. So what we do is we compile them using our library compile from RE, and we get emoji patterns. This one is stored in emoji patterns. Now we substitute our string, whatever string that appears in this function, we substitute it with this blank. This is actually blank, just means nothing. So here you can see if we call this on game is on fire emoji, then it removes the fire emoji and we get this. Again, if we call it on hilarious and this emoji laughing face with teardrops, then it removes the emoji and we just get hilarious. So that's how we remove the emojis. Again, for emoticons, emoticons are a bit different. Like this is a smiley emoji. This is above it is a smiley emoticon using English grammar symbols. If you make expression using English grammar symbols, that is emoticon. So here we have our dictionary, the whole dictionary for many emoticons. It's available on GitHub at this link. It's a pretty big dictionary. Yeah. So after all these emoticons, how do we remove them? So again, we use regular expression. We need to add actually couple of separations here, like Unicode.
Yeah, just a second, someone. So because before we use to choose to remove them, as you can see, like you have to declare them in emoticons, like what emoticons you want to remove. So in this above, just go above someone. So see all these emoticons we have already defined here. So these all kind of emoticons we are removing, and we are declaring. Go ahead, go on the top, go on the top here. Yeah, here. Just come down, come down, come down. So all this emoticon, as you can see, we have declared with the help of a dictionary. And then we are using this, storing it in emoticon dictionary, and that we are using in regular expressions. So regular expression, as I said, will be more clear to you when we regularly cover it in a class. So I will cover it, all the coding of regular expression in a class for you. So right now, just take it for granted. All your sound.
Yeah. So again, we just need to couple of Unicode strings because for the emoji separation, and then we join all this dictionary K for K in emoticons plus U because it's actually in Unicode. If you see here, this is Unicode string. So we need to do this and return emoticon. So we just call this substitute function. Again, this substitute function takes in uh, whatever target we have. So this is our text. Our text is the target and replaces any emoticon found. If any emoticon is found, it will replace it with blank. So if we see here, this hello and then this smiley face emoticon, it is removed by blank. It is
No,
just
no,
removed.
Soman, it is not replacing it with blank. Actually, just it is making it disappear from there and leaving nothing there. If you see between hello and that emoticon, there is a space. And when you remove the
Yeah.
emoticon, still space will be there. So this
Hmm.
space is not added by this function actually.
Yeah.
So it is just replacing it emoticon and leaving nothing here actually. Just disappears from there.
Hmm.
So leaving nothing there. So you just see. I am said after that also there is a space. That's why you after removal also you see a space. Actually, this function
Yeah.
is not removed. Yeah, go ahead, Soman.
Okay. Thank you, sir. Now, conversion of emoticons to words. So, as said earlier, sometimes we need our emoticons to actually express our feelings. Most of the emoticons are feeling related. So, in sentiment analysis and kind of these things, we would appreciate if you have emoticons as well in our strings or text. So, in order to convert those emoticons, we substitute them. So, we need to first take the emoticon. So join emoticon emote. So whatever emoticon we find in text, whatever emoticon that we find in text, we split it and replace comma with blank because sometimes they are comma separate. We replace comma with blank. Whatever emoticon it is from the above dictionary, we can get that emoticon and we join them using this underscore. So we'll get this happy face smiley. So this a single string, and then we call this RE sub.
And
So
if you want, you can replace that underscore with a space. So that
yeah,
suppose right now happy space smile is coming with a underscore, na? So just
mm,
replace it with a space, remove that particular thing, replace it with a
this will
space, then it will be a regular, it will look like a regular sentence.
yeah,
So what I'm telling here is the beauty of these functions, whatever you are getting here in this file, is that you need not bother about the code. Just pass the text and use as it is this function in your data cleaning. Whenever you do data cleaning in your project, just you can use this function as it is without bothering what is there inside the function. Just pass the text and get the desired output. So this is the beauty. They are reusable functions which you can use as it is in your projects. Yeah, all yours, Soman.
okay. So again, we just call it on text. We have some text, we pass it to the function, and we get like hello, and there were two happy face smileys. So hello, and then we have these two happy face smileys as strings. Now we better have this something for emojis as well. So here again we have the dictionary. So each emoji, so whatever the description of that emoji be, first place medal, second place medal, and their Unicode. So kind of really big dictionary. You know there are thousands of emojis in our phone. Let me get to the end of this.
You see, it is a pretty comprehensive list. So right hand side, Unicode, whatever you see, that represents the emoji image. And left hand side is its meaning actually, meaning text.
Yeah.
So you can use it and same as emoticon you did, you can do it for emoji concepts as well. So code is not much different. And still, if you don't understand the code, just use the function as it is. So you can use it in your
Okay.
project as it is.
Okay. So first of all, we need to since we need to get meaning from emojis or the meaning of those emojis. So first, this dictionary is actually in the form of meaning as key and the Unicode as value. So we need a reverse dictionary. So to get the reverse dictionary, we just call this VK. This is just as list concatenation. We have dictionary concatenation. So V and K. We just replace key values by value key. So value becomes the key and key becomes the value. we will just be getting a reverse of this dictionary. Means this one, the Unicode will become the key, and the value will be this description. That's all. That will that's what we'll get from the code. Next, we declare our function. So again, we if there are multiple words, we join by underscore. We get if we encounter any emoji in our Unicode, we call that emoji from the dictionary. We replace any comma if they are comma separated. We replace it with blank. If there are colon separated, we replace it with blank. Blank means nothing. We remove commas and colons, and we split the text, and finally we join them with underscore. So and that we substitute this emoji with uh, whatever text we get from this. So here we have, if we call this function on this, game is on fire. This is fire emoji. So we convert it and we get this. The game is on fire. This translation of emojis. Again, text hilarious. This emoticon. So we get face with tears of joy. That's how we convert emojis into text.
Yeah, just a second, so just as I said, if you replace that underscore with space, then it will look like just hilarious space with space tear space off space joy. So it will become a regular looking text in English, which you can analyze as in which using your regular NLP techniques.
Yeah. Next up, we have removal of URLs. So sometimes there are URLs present in our text. So again, we call regular expression, and we give this, all these are URL tags. So whatever or URLs begin with HTTPS, they are question marks for values. They are separated by these double slashes, forward slash, backslash, www dot. So for all that, we just pass this particular all these combinations, and we just return URL pattern. Substitute with nothing means remove it, and our text. So whatever be the URL in our our text, it will be removed. Like here we have driverless AI NLP blog post on, and this URL. If we call our function, this URL is removed. Now let's take HTTP URL and check the code. So again, this it's simple. Since we are using regular expression, it understands the HTTP or HTTPS. That doesn't matter. We can add multiple. So after removing URLs, there are a couple of examples. This one was www.h2oai.com. So this URL, it didn't have HTTP tag, but still the website, it removed it too. Next, HTML tags. Sometimes when we get data, if we are getting data via web scraping, if we take from web scraping, uh, that actually appears here. If you see the spec tag here, whatever our web page looks like, it is in this form. Like these are all HTML tags in our the HTML tags in our web page. So if we are taking data from our web page, so it will obviously come with HTML tags like div, h1, paragraph, and this aref, ahref. So in order to remove all these HTML tags, what we do is we can call the RE compile, regular expression compile. These are HTML. These symbols are actually used to define HTML tags. You can see uh, these are in between greater than and less than sign. So we just pass these tags and return HTML, substitute with nothing and text. So if you see here, all these are removed. Dave is removed. The H2O was heading 1, so it removed the heading 1 tags and just this returned just listening HTML. Again, AutoML was in paragraph tag, so we just got paragraph tag. This one was actually link. Uh, this link was provided. This link was embedded in Word driverless AI, so it removed the link tag, uh, link as well as the A tag, anchor tag, and what we got was just driverless AI. Instead of doing it with regular expression, all this is actually built in with Beautiful Soap. Beautiful Soap is actually a library provided for web scraping. So we just call Beautiful Soup. Beautiful Soup automatically removes all the HTML tags. So we have to pass the language actually. So LXML is actually HTML, and we pass our text in it. So whatever text, it will remove the HTML tag. So again, we can see for the same example, we have same result from the function made with Beautiful Soup. Now, chat word conversation, sometimes we use abbreviations for our text like be right back, BRB, got to go, GTG. So we can replace those abbreviations with strings as well. So let me see. Yeah. First, we need a chat words map dictionary and a chat words list. So from this above whole string we have actually we add in form of string. So whole string we split it by new line. So every time there is a new line, we split our string. If the line is not blank, so this actually for empty string representation. So if it is not empty, then we split it. We split the line. So you can see split with this equality operator. So if they are separated with this equal sign or equality, then we know that zeroth index means zeroth index will have this part and the first index will have this part. So zeroth index, so that goes in the chat word, CW chat word, and this expanded or the full form of that is actually at first index. So again, line dot split at equal first index. Next, we have chat words list, which we have declared earlier. So we append the chat word and we create a dictionary that for each word their meaning. Again, instead, because this was in the form of string, we have converted it into a form of dictionary. Each chat word as key, sorry, that expression as key, and its meaning as the whole word. So we get the chat word list. We call the set in case there are repeated. So just to keep all the unique words, we just call set. Now this is our function. We have we call a list for new text. We text for each W in text dot split. So we for our text we call the split method for each word. For each word, we convert it into uppercase because if you see here, these are all in uppercase. So we need to convert each word into uppercase. Uh, and if that word is in our chat word list, then we append the new text with chat words map dictionary. Uh, from this dictionary, we take this meaning. From the dictionary, we take this meaning from the key because the chat word is there. So w dot upper that becomes our key. We take the meaning out of the key, so it will return the value of that word, and that will be appended to a dictionary. Else, just append the word as it is without doing any conversion. Means if it is not a chat word, it will remain the same. So and then we just convert the list back into a single string, space separated string. If we call it on 1 minute BRB, we'll get this one because it is not chat word, it will remain same, minute will be same. BRB, it will appear in the dictionary. BRB converted to upper will be in check word list. So it will check it in dictionary. BRB has the meaning be right back. So that will be appended to our new text dot list, new text list, and after conversion we'll get this
And
be right back.
just a second, Soman. Sorry for the interruption. So I want to make a just line that sometimes these BRB and like I will be right back. So these things people don't type in capitals. So in that case, you have to little bit modify that if dot upper and those things, those kind of things. That much code you have to modify,
Yeah,
and you can use even without even if it is in lowercase. You can either convert it into uppercase or just a little bit modify this case to little bit modify this code to handle both uppercase or lowercase.
no,
And
sir, it has the uppercase now, so it will
yeah,
always consider that if it is in lowercase, it will come. Like here in the example,
okay,
IMO is in lowercase, but it
great,
again converted into uppercase. That's
great, great. So spelling correction is the last one, I think.
yeah. So spelling correction in because sometimes we there are misspelled words, so we need to install the PySpell checker, and from this spell checker we import spell checker model and we create an spell. Next, we have a list of corrected text because we'll just split our text and correct in each and every word. So if a particular word is unknown, means if it is a misspelled word, it won't be in a dictionary, right? In English dictionary, that word will not exist. So that's why unknown. So if any unknown word is encountered, that ends up in misspelled words. Now, for word in text dot split, if word in misspelled word, now we again uh, split that text, and for each word, if that word is a misspelled word, then we append the list with spell dot correction. So this will return the correct spelling of word. The correct it will take the word, it will correct it. The spell dot correction will correct the word and then append it to our dictionary. Otherwise, if it is a correct word, then we need not to do anything. We simply append it, and again we convert it into a space separated string. So here the example text is equals to spelling correction. This both the words are misspelled. So after calling this function, what we get is spelling correction. See, this is correct. The spellings are correct. Next is thanks for reading the notebook. So thanks and reading, they are spelling mistakes. So correct form will be thanks for reading the notebook. That's it. So that was all from my side today. Thank you very much.